Hey guys, so welcome back to the channel. This will be a short video on the implementation of the queue data structure in C++. So as of my previous video, which was on the implementation of the stack data structure in C++, using both the array and the linked list, this will be only and this will only be a linked list based implementation for the queue data structure. So I'll start off by creating my file, and I'll name it as queue.cpp. So I'll start by including the string, and now I will be using the namespace, and now I will create my class node. So inside this class node I will have my public member variables and constructor for this class. So I also wanted to add that as of the stack data structure, which follows the first in last out methodology, the queue data structure follows the first in first out methodology, as that the first element to enter the queue is also the first element to leave the queue. So now I will be creating my class queue, which will contain the functions for this specific data structure, along with the pointers to the front and the rear of the queue. So I'll name the pointers as a front pointer and a rear pointer as private member variables. And now in the public section, I need to create a constructor for this class, which would uh, basically assign the front to be equals to null and the rear to be equal to null. So now the queue data structure will also follow the same functions as of the start data structure. So our first function would be a push function for this data structure that will basically insert a value to the queue. So uh, first of all, we need to create a new node. I'll name my node as temp. And now after creating a node, we need to check that if the queue is empty. So we need to check that if the rear is equals to null pointer. We basically need to assign front and rear to be the new node. And in the else case, if the queue is not empty, we need to point rear's next to be equals to the node we created, and we then need to update our rear to be equals to temp. Yeah, so this would be the push function for the queue data structure and this class. And now moving on to our next function, which would be a pop function to remove an element from the queue. So for this function, what we need to do is that again we need to check that if the queue is empty. So if the queue is empty, we will check it by checking that if the front is equals to null pointer. We simply need to print that the queue is empty, and we can return an error value. Okay, I forgot to add an end line over here. And now in the else case that if the queue is not empty, what we need to do is that we need to store the value in the front pointer in another variable. I'll name it as int variable is equals to front data. And now what I need to do is that I need to create a node to basically store the front of the queue, and we need to update the front to be equals to fronts next. And now I again need to check that if the queue goes empty after directly popping an element. So I'll again use the same if case, that if the front is equals to null pointer, what I again need to do is that I need to assign rear to be equals to the null pointer. And now we basically need to delete temp, and we need to return the variable we basically created to store the data of the front pointer. So this will be for the pop function for the queue class. And now I would be moving on to the next function, which would be a peek function, which would basically return the value at the top of the queue, basically at the front of the queue. So it will again be an function with an integer type return type. So our first task would be to use an if case to check that if the queue is empty again, that if the front is equals to the null pointer, we basically need to tell the user that queue is empty and return an error value. And if this is not the case, that if the queue is not empty, what we need to do is that, okay, so there is a spelling mistake. So in the else case, what we need to do is that we need to simply return the data the front pointer is basically holding. Yeah, so this would be it for the peek function 2. And now moving on to our main function to check that if our code is successfully running, we need to create an object first of all. So I'll name it as q1, and I'll push multiples of 5 in this data structure. Yeah, so it would be 10, this would be 15, and this would be 20. And now I need to check that what the element is at the front of the queue. So the element at the front of the queue is, so we basically call our peek function. So q1 dot peek, and then with the handle. Yeah, so and now I will show you guys if the code is working absolutely fine, and then we'll test the pop function too. Yeah, so it should basically show us 5. Yeah, so it is the element at the front of the queue, and the code is working absolutely fine. So as I told you guys that the queue in this data structure, 5 was the first element. As you guys can see, the first element to enter the queue was 5, and the first element to leave the queue would also be 5, as it is present at the top of the queue. So I will again perform a pop operation. So q1 dot pop, and now I will again call the peek function to check that if the value has successfully popped out of the queue. So the element at the front of the queue after the pop operation is, so it should be basically the next value. Yeah, so it is 10. So this code is working absolutely fine. So this was it for today's video. For any of your doubts or question, leave your queries in the comment box. I will be back with another video on the next data structure, which will most probably be binary search trees and binary trees. So like, share, and subscribe.